Okay, so let's move on to the second part. Okay, so the question 39, a cubic cheese. Okay, so here is the three-dimensional coordinates. So we know x, y, z are 1, right? So it's like a square. Okay, so we have this one. So x, y, z. So we're cutting it along the three phase lines, right? The first is cutting through here, right? The second line is cutting through here. Y equals z, right? Yeah. The third one is cutting through here. X equals z. Okay, so we have the three phase. Okay, then cut it through. Now the question is asking you how many parts of the of this of the cube has been cut into. Okay, so now let's solve the first part. Is this okay? Let's draw it. This is the first part, right? So this is the first cut, right? And the second cut is through this. Right? The second cut is through this. So here is this. And the second cut is also parallel to here. Okay, so after the first cut is 2. After the second cut, this is the 2, this is the 2. So we have the 4, right? And the third cut, you can see, okay? The third cut is through here, right? Let me use another color. The third cut is through here, right? So we have this cut and we have this cut. See, what you can see is the third cut actually only cutting the top face, only cutting this part. It doesn't cut in this part. And it's the same thing. The third cut is here, right? It's only cutting this piece, but not this piece, right? So here is this one cutting into 2, this one cutting into 2, and we have 2 pieces not cutting. So the total is 6. Next. So the EFGH is a cube. So this is the cube, okay? It asks us how many different planes passing through at least the 3 vertices of this cube. So let's see, is there any vertices, is there any plane, okay, pass 5 points? So that means, is there any of the 5 points that is on the same plane? Okay, so from all of the cubes, okay, the maximum points that on the same plane is 4. So that's why you can only, one face can only pass in 3 points or 4 points. Okay, let's see how many of the 3 points. Okay, the 3 points is, we pick this one, right? It's IKF, right? or IKH, right? And also you can, if you can pick the EGJ or the EGL, right? So basically, if you pick the IK and the EG, there are 4 of them. And if you pick the GL and the FH, there is another 4 of them. They all passing through the 3 points. Okay, now let's see the 4 points. The 4 points, you have 6 surface, right? And also you have the EGIK, right? You have this one and this one. That's another 2, right? And also you can take the EH and JK, right? GF and KL, that's 2, right? This is another 2, right? And this is another 2, and this is another 2, right? 1. Okay, so let's see. You can take this one, you can take this one, right? That's 2, and you can take this parallel and or this parallel. You can take this parallel or this parallel, right? So that's 4. So total is so in the cube, the A, B, C, D, E, F, G, H is shown in this. So every line is 12, so find the distance from the B to the plane of the ACF. Okay, so B to the ACF, we can use the 2 ways to solve the volume. And let's see, this is the H, right? So B to the ACF, let's see, it's H. Okay, so we can see the volume of the B to the ACF in one way is equal to the volume of the C to the ABF in the second way, right? So now let's solve the first way. The B to the ACF is equal to the 1 over 3 times the base. The base is root 3 over 4, right? The side length is the 12 square root of 2 of the square, right? Then times the height of the H. Okay, now let's solve the C to the ABF. Okay, it's 1/3 as well. The ABF, okay, is a half of the 12 times the 12. Okay, then we times the height. The C to the ABF, okay, the height is also the 12. Okay, because these two are equal, then you can solve the H is equal to 4 root 3. So next, the sum of the length of the 12 edges of a rectangle box is, okay, let's draw a rectangle box. So we have is A, B, C. Okay. So the corner from one corner to the opposite corner, then will be, we know the a squared plus the b squared plus c squared will be 21 squared, right? And the 12 edges, right? So we have the 4 of the C, 4 of the A, and 4 of the B, right? 4 of the A plus B plus C is equal to 140. Okay? So what is the total surface area of the box? So the total surface area, if we have A times C, we have 2 of them, right? And we have the B times C, we have 2 of them. And A times B, we have 2 of them. This is the surface. Okay, so we know this 2. We know the 1 and 2. We try to solve the S, right? S is equal to this, is equal to A plus B plus C of the square minus the A square plus the B square plus C square, right? So this one means it is the 35 square minus the 21 square, right? So we use the difference of the square, then it will be the 6 and 56 times the 4 and 14. So the answer is 784. So next. So we know the congruent of the wedges of the A and B, and they are sliced in different ways. Okay, so each wedge has a pair of the parallel lines on the surface. For the wedge A is cutting to vertically, for the B is cutting to the horizontal. Okay, so each of them is are made of, so 6 pieces are cutting of the slice of the a quarter-inch thick are cut from each wedge. So what is the ratio of the remaining of the volume A? Okay, so for the A, let's see what's the remaining. Okay, so the remaining is the total, right? So let's assume the total volume is K. They are both, right? So let's take a look at the ratio, right? So we cut off a quarter, each one is a quarter times 6, right? So basically what is the left? It's a okay, so we have 12 inches here. We cut the 2 over 3, right? So now we can calculate the remaining. So the V remaining is equal to the 12 minus the 2/3 over the 12 is 1 minus the 4 is 1/8 is 7 over 8 of the K. Okay, so this is the remaining of the A. Okay, now let's see what's the remaining of the B. Okay, so it's the same thing. We need to draw this because it's cutting horizontally, right? So here is the 10, here is the 6, right? So we know we cut into the 2/3 piece, right? So 2 over 12 is 9 over 2. Okay, so now we want to see. Okay, so what is the volume we cut here? Okay, so we can see the ratio of this one to this one. Let's calculate the ratio. Okay, so the 3 over 2 over the 12 over 2 is 1 over 4th. Okay, so here is 1/4 of that. So now, we can see now the area. Okay, this is the area, right? Extending. So the area is 1/4 of the total, and the height is also 1/4 of the total, right? So now what we cut is 1/4 of the S times the 1/4 of the height. Okay, so that's we cut the 1/16 of the K, right? So the remaining That's why the V remaining is 15 over 16 of the K in the B. Okay, so the calculation is what the ratio of the remaining of the volume A to volume B, right? So this is the A and this is the B. Then we can see the VA over the VB is equal to 7 over 8 and 15 over 16. So that's why it is 14 over the 15 is the ratio. Okay. Next, so the ABCD, the ABCDEF is shown is a regular octahedron. Regular octahedron, okay, with the edge length of the 1 and the midpoint of the edge of the ABCD, ABACAD, ABAC, AD, AE. Okay, that's the midpoint. Okay, and the other of the midpoint is the BF, CF. Okay, so we have two sets of the midpoint. We have two sets of the midpoint QRST respectively. Okay, so we want to find the MNOP and the QRST. Okay, so the MNOP and the QRST, you can see it's symmetry against this, right? So what we try to solve is, we know it's easy to solve the base area, right? What we want to solve is the height, right? Okay, so you can see, maybe let me draw a big picture here. Okay, let me draw the, okay, so what you can see is you want to calculate the height of this, right? This is the half of the height, right? But if we land from this one to here, okay, you can see this height, okay? So this is half of the height of the regular octahedron, okay? So now let's see this. So this is the half, everything is half, right? So the surface of the area is equal to, with the length of 1, right? So this is the 1, this is the 1/2. So it's half times the half, so that is 1/4 of the surface area, okay? So now let's calculate the height, half height of the regular octahedron, right? Let's take this is the M, okay? This is the A, and this is the O. Okay, so we know that this one is 1/2, right? And this one is √3 over 2. Now we can calculate the AO is the 3 over 4 minus the 1 over 4 is equal to the 2 over 4 is the 1 over √2. Okay. So now we can calculate the volume, right? The AO is this is the half of the AO, but we have another part, right? So the height is the 1 over √2, right? So the area, the volume is 1/3 of the face times the 1 over √2 is the 12. Oh, I'm sorry, no 1/3. So that's equal to the √2 over 8. Okay. Then the parallelogram EFGH has a base of the right prism at the right above, and given the EF is equal to the 8 and the FG is equal to the 6, so the EI is equal to the 9, and the EFG is equal to the 60 degrees. We want to find the EK and the FL. Okay, so if you want to find the EK and the FL, right, and it's better, the key is to find the FH and the EG, okay, because the FHL is a right triangle, okay, and the EGK is a right triangle, so we need to find the base, okay. So now let's draw it in this way. EFGH, okay, so it's 8 and 6 and 8 and 60 degrees, okay. Now let's land a height. So this is the 30, 60, right? We know it's 3. Now we know this one is 5. Now we know this one is the 3√3. Okay. Now let's solve the EG. Okay, so EG is equal to the 5 square plus 3√3 square. Okay, so this one is 25 plus the 27 is root 252 is 13 times 4 is 2√13. Okay, and we can also do here is 6 and 3. Then we can solve the HF. The HF is 3 plus 8 is 11 square plus the 3√3 square is equals to 121 and 127, right? 121 plus 27 is the 148. Okay, is 2 of the 37. Okay, now we can try to solve the FL and the EK, right? So the FL is equal to FH (148) plus the 81. Okay, the EK EG squared plus 81 is equal to okay, so next is we have a right square frustum is formed by cutting a right square pyramid. Okay, we have a right square pyramid. With a plane parallel to its base. Suppose the original pyramid has the base length of the 6 and 9, base length of the 6 square and the height of the 9. and that the plane cutting to the pyramid is 9 and is 3 units from the base. Okay. Okay. So find the volume of the first room. Find the total. Okay. Now let's solve this. Okay. So we know this is the 3, right? This is the 9, right? So we can calculating the we can use the volume of the original the original what's this, what the original of the pyramids, okay, minus the the one we cut off, then it's the rest. Okay, so let's see the ratio. Okay, then we need to figure out the ratio. Okay, so here the ratio is here is 3, right? So here is 6, right? So the ratio is 6 over 9 of the sides, right? Is 2 over 3. Okay, so you can see the area is also have the same ratio, right? So the V cut over to the V0, okay, is equal to the 8 over 27, right? Is equal to the ratio of the cube. So now we know how many we cut is 8 over 27 of the V0, then the V first term is equal to the 27 is 19 over 27 times the V0. Okay, now we need to solve the V0, right? So the V0 is equal to the 6 times 6 times 9. Okay, so it's 36 times 3. So now let's solve here. So it's 19 times over 27 times 3 times 9 times 4. So it's the 4 times the 19 is 80 minus the 4 is 76. That's the first part. Okay, so the second part is the surface of the pyramid, right? So the surface of the pyramid. So we know the length of this, right? So it's the 2/3 of the 6. So this is a 4, and this is so that we try to solve the AM first. Okay, let's solve AM. Is we have the 3, we have this one is 9. So the AM is equal to the 3, then it's root of the 17. Wait. 3 times 3, 10. Okay, 3 root of the 10. Now this one is 3/3 of that. So the height of the isosceles trapezoid, okay, will be the 1/3 times the 3 of this is the height of trapezoid is root 10. Okay, now we can solve the surface area of the a trapezoid. Okay, so the surface area of the trapezoid is equal to half of the 6 plus the 4 times the root 10 is equal to the 5 of the root 10. Now the surface area will be equal to 4 of the trapezoid plus the 6 times 6 plus the 4 times 4. Okay, so this will be the 20 root 10 and the plus the 52. Okay, now the final one. So let the ABCD be a regular tetrahedron. Tetrahedron ABCD. Okay, ABCD. It has the length of the 2. Okay, we have a plane and parallel to the edge of the AB and lie the halfway between them. Okay, so we have a parallel like this. Okay, so land between halfway of them, and let's find the surface area of such of the piece. Okay, so the surface area, you can see the surface area is 2 ones, right? And the 2 of the trapezoid, and then is on the top is there is a, at least this is the parallelogram, right? Because this parallel to this parallel to this. The one we want to prove is this one and this one, right? Are perpendicular each other, right? So how to prove they are perpendicular each other? It's very simple. Okay, let's land on the midpoint here. Okay, so you can see this parallel to this, right? This parallel to this. You can see here is the height, here is the height. So the CD, right? The CD is perpendicular to AM and CD perpendicular to BM. So the CD is perpendicular to the face of the ABM. Then the CD will perpendicular to the AB. Okay, now you know it's perpendicular, right? So here is a square. Okay, the middle cut is a square. Now we solved everything. Now let's do it. Okay, so let's solve the area of the trapezoid. Okay, so we know this is the trapezoid is a 3/4 of the triangle area. Okay, is the √3/4 times the 2 square. Okay, so this one is 3√3/4. That's one of them, right? Then the triangle is 1/4 of the equilateral triangle. Okay, so this is the 4/√3. Okay, so we have 2 of this and we have 2 of this, right? So the surface area is equal to 2 of the trapezoid and the triangle, then plus this one, right? It's 1 plus 1. So this one is the 2√3 plus 1. Okay, so that's it. So thanks a lot and for watching the video of the solution to this chapter. Thanks a lot. Bye.